Here's example 1 of using half-angle formulas. So here we have to evaluate sine of 15 degrees two different ways. So we've done some stuff like this before with the sum and difference angles. So for this example, we're evaluating this two different ways. So one way is going to be with the sum and difference formulas that we used before, and the other way is going to be with the half-angle formulas. And we'll make sure that the answers we get are the same. So first let's do it the way we've done it before, using the sum and difference formulas. So if you want to copy this formula sheet to follow along with, check the video description. There's a link in there. You can use that link to get a copy of this. So, so the idea here, if we use the difference formulas, so we have sine of 15 degrees, the idea is to express 15 degrees as a sum or a difference of two special angles on the unit circle. 15 degrees is too small to be a sum of two special angles on the unit circle, so we're going to have to express it as a difference. So what we can say then is that 15 degrees equals 45 degrees minus 30 degrees. Okay, or we could do 60 degrees minus 45 degrees, but let's just move forward with that. So sine of 15 degrees is the sine of 45 degrees minus 30 degrees. Okay, so we're going to use the formula for the sine of a difference of two angles. So this will be our alpha, this is our beta right here. Okay, so then what we have is the sine of alpha minus beta. And if we look at our formula sheet here, we see that the sine of alpha minus beta is sine alpha cosine beta minus cosine alpha sine beta. So this is going to be sine of alpha, which is sine of 45 degrees, times the cosine of beta, which is cosine of 30 degrees. And then it was minus cosine of alpha. Alpha is 45 degrees. That's a 5. And then times the sine of beta. And beta is 30 degrees. Okay, so from here it's just a matter of knowing the unit circle. So sine of 45 degrees, that's root 2 over 2. And then we have cosine of 30 degrees, that is root 3 over 2. Then we have minus cosine of 45 degrees. Cosine of 45 degrees is also root 2 over 2. And then sine of 30 degrees is 1/2. Okay, so then simplifying everything, so root 2 times root 3, we saw a lot of stuff like this before when we talked about the sum and difference formulas. Root 2 times root 3 is just root 6. So we have root 6 over 4. 2 times 2 is 4, and then minus root 2 times 1 is root 2. 2 times 2 is 4. So then what we have is just root 6 minus root 2, all divided by 4. Okay, so that's the answer one way, using the sum and difference formulas that we've used before. Now we're going to do this a different way using the half-angle formulas. So with the half-angle formulas, let's set aside some space here. Alright, so with the half-angle formulas, then what's going on is sine of 15 degrees. So the idea is to say, okay, 15 degrees is half of what? So 15 degrees, so we'll say sine of 1/2 of what? 15 degrees is half of 30 degrees, right? So that's going to be 1/2 of 30 degrees. So in other words, that's going to be sine of 30 degrees divided by 2. Okay. So if we look at our formula sheet here for half angles, so here sine of alpha over 2 is plus or minus the square root of 1 minus cosine alpha over 2. So we're going to use that formula with 30 degrees as our alpha. Okay. So that's going to be plus or minus the square roots of 1 minus cosine of alpha, which is 30 degrees, all divided by 2 inside of that square root there. Okay, now the question is, which do we use, the plus or the minus sign? Well, notice here, and we did talk about it in an earlier video, this plus and minus sign is determined by the quadrant of alpha over 2. So alpha over 2 is 15 degrees, right? So alpha is 30 degrees. Alpha is 30 degrees, and alpha over 2 is 15 degrees. Which quadrant is 15 degrees in? 15 degrees is pretty small. It's smaller than 30 degrees, right? We know 30 degrees is in the first quadrant, somewhere around here. So 15 degrees is half of that, so it's somewhere here in the first quadrant. Okay, it doesn't matter exactly where, all that matters is that it's in the first quadrant. So if you're in the first quadrant, then sine, S-I-N, sine is positive. So we're just going to take the positive square root here. Okay, just take the positive square root. So really we don't have to write anything at all, just plus sign to be explicit, but we don't need anything there. Okay, so since 15 degrees is in the first quadrant, this is going to be the positive square root. Okay, now from here we just proceed with the evaluation. So This is the square root of 1 minus cosine of 30 degrees, that's root 3 over 2. And that's still all being divided by 2 inside of the square root. So now what we can do is get a common denominator in here. So 1, we can multiply that by 2 over 2. So then we'll get a common, let's zoom in a little bit here. Then we'll get a common denominator on the top here. Okay? And we're going to have, the square root is still there. So we have 2 over 2 minus root 3 over 2, all divided by 2. Okay? And then that's going to be 2 minus root 3 all over 2, and then all over 2 again. So we have 2 minus root 3 over 2, all being divided by 2. So that's, let's come up here a little bit. That equals the square root of 2 minus root 3 over 2, and then dividing by 2 is like multiplying by a half, so we have that going on inside of the square root still. And then that is going to be the square root of 2 minus root 3, all divided by 4. Well, square root of the top divided by bottom, that's the square root of the top divided by square root of the bottom. Square root of the bottom can be simplified, so this actually turns out to be square root of 2 minus root 3, all divided by 2. Okay. So you can split this square root up into the square root of the top divided by the square root of the bottom, and the square root of the bottom is the square root of 4. The square root of 4 is just 2. So this is our answer here. Okay. So notice that looks pretty different from this, right? So root 6 minus root 2 all over 4. Let's zoom out a little bit. And then using the half angle formula, we have the square root of 2 minus the square root of 3, all divided by 2 here. Okay. So are those actually the same? Let's turn to our calculator and make sure that those actually are the same. So let's see. If we zoom in a little bit here, now let's zoom in over here. Alright, so one of them is root 6 minus root 2 all divided by 4. So let's enter that and see what we get. So we have the square root of 6 minus the square root of 2 all divided by 4. Okay, we want an approximate value of that. So that's approximately equal to 0.2588190,451. All right, and the other one was, we'll zoom back out to check it again. The other one was square root of 2 minus the square root of 3 divided by 2 like this, so kind of goofy. Okay, so then that one is the square root of 2 minus the square root of 3 divided by 2. Okay, and then that approximately equals the exact same thing, 0.2588190,455. Again, it's just an approximation because these are irrational numbers, so there are no finite decimals here. It's just an approximation out to so many decimal places. But anyway, we do see that they're equal out this far, so we can safely assume, for our purposes anyway, we can assume that they are exactly the same. So that's just a verification there. Even though they look completely different, you know, this second one looks kind of goofy here with the square root inside of the square root and everything, but they really are the same number. And there are ways, better ways of showing that really. You can algebraically manipulate one of either of these to make it look like the other. But anyway, the point here is that sometimes with these trig expressions like this, you can evaluate them more than one way, and you might get answers that look different, but they will be the same if everything was done correctly. Okay, so that's example 1 with half angle formulas. Evaluate sine of 15 degrees 2 different ways. And the same answer 2 different ways looks pretty different, but it is the same number.